So, hello. So nice to see all the people here. I am Madis. I'm a developer experience engineer at Veriff, and I'm going to talk a bit about how we do system-wide end-to-end testing at Veriff, so how we test Veriff as a whole. But before we can test anything, we need to understand what the product does. So I'm going to give you like a quick 5-minute intro in what Veriff is. So we are building a base infrastructure for trust online. And often you could say that we help our customers to meet their KYC or know your customer regulations. So let's say you're opening up an account on a crypto exchange, or maybe you want to transfer a large sum. We help these companies to verify their users and fight fraud. And you wouldn't be wrong. That's like definitely a core part of our business. But there are so many other use cases as well. It's not only fintech. So maybe you want to order some age-restricted items, like alcohol, to your party using a food delivery service. And then you need to verify your age. We help with that. Or maybe you are running a fully remote company and you're thinking, how can I onboard my employees without ever seeing them face to face? How can I give them the passwords to our infrastructure? We can help with that as well. So in all of these cases, we are in a very critical path of services like a sign-up or a key transaction flow, and we're directly affecting their conversion. So how does all of this work technically? We're a bit like Stripe. We're an API. So it starts with a user and our customer, let's say a bank. And the user wants to open an account in this bank. So what the bank does is they hit our APIs saying like, let's create a verification session. I want to verify a person. And we send back this magic link. And it actually really is a magic one. We really have the magic in the URL right there. So the bank then forwards this to the user's phone, where it's opened up in a browser. And they go into another service on our end, it's called Front, and they go through what we call end user flow. But what it really means is you're just showing yourself, your face, your documents to the camera. We gather all this data, we push this into this magic box full of pixie dust, linear algebra, machine learning, all kinds of things. And out of that box, we reach into a decision. We send that to the bank. And the decision is very simple. Is this person who they say they are or not? Is Madis, or maybe it's Tom, maybe it's some malicious user trying to fraud something, whatever, yeah. And we also tell the user, like, cool, you're done, you have gone through the flow. They can proceed and open their bank account and start doing transactions or whatever they need to do there. So all is very nice and fine there. But sometimes, with all of these systems, it doesn't work. You would see a screen like this. Something went wrong. Maybe one piece of the API broke. Maybe this magic Veriff box there broke. So we got an incident, and it's a bad day for everyone. At Veriff, what this means is a bunch of engineers get woken up in the middle of the night, they get a phone call, they need to log into their laptops and start working on what went wrong and start fixing this. So we are having a bad day. Our customer is also having a bad day because suddenly their user sign-up flow isn't working. Like conversion metrics are dropping. The most core part, the KPIs, the key performance indicators that they are monitoring are dropping. So obviously it's a very bad day for them as well. And finally, and I would say most importantly, it's a really bad day for the user who is holding this phone in their hand and they're seeing this screen. Because maybe they want to send money abroad to a family member and they're blocked by this. Maybe they're trying to get access to their work account and they couldn't. They're stuck and they cannot get any work done. Or maybe there's a party going on, they're running out of booze, and it's a total buzz killer. So in all of these cases, we are ruining someone's day, and that's really terrible. So as a background, this started happening more and more as we grew. Over the past 3 years, we have turned into a unicorn. We have around 330 repositories today, up from 100 just 3 years ago. We use microservices, so we have 150 unique services deployed today, up from 60 in 2019. And our engineering team has grown from tens of engineers to teams, tens of teams of engineers, so more than 100 people working on this system. And as we grew as a company, our ambitions grew as well. So we are internally targeting something that in the industry is called 5 nines. So it's this very aspirational target of having an uptime of 99.999%. And that's a very, very aspirational goal. If you put it into numbers, it translates to just 6 minutes of downtime per year. And that's not a lot of time. Like, let's say if an incident happens, and you are actually calling people and waking them up, probably it takes at least a few minutes already just to get them into the laptops. Then they only have 4 minutes to figure everything out. So that's totally unreasonable. So from our perspective, we wanted something that would catch these issues before they even hit the production. And the issues would be something like, maybe a service would make a backwards incompatible API change, breaking the mobile flow for all their SDK versions. Or maybe an internal message passed between two services was working well, but we didn't know that a third service was also listening for that message. We changed the format, and then suddenly this third unknown service started crashing a lot. And all sorts of these issues would pop up, and we would have a very hard time hitting that target. So I'm at a testing conference. I know what you're all thinking, like unit tests, integration tests, manual tests, contract tests, end-to-end tests, like all of those things. We do all of those things as well, but what I really want to talk about today is end-to-end tests. Because with unit tests, I think you've all seen like some of these funny pictures online. Like you have two windows in isolation in the factory. They all work perfectly well, but if you put them together, then suddenly it's not really working anymore. We are also doing manual tests, especially for if we ship binaries like SDKs that you send out, and there is a very costly way of upgrading them. So there we really want to do manual tests before we send anything out. But for these like 150 microservices, doing a full Veriff manual test every time somebody wants to deploy would be too slow. So we wanted to build this end-to-end test suite to catch this. And very nice way to think about this is as signals. So imagine you're in a plane cockpit, and the plane is your product. And you have all sorts of these kinds of signals, like the test failures. Maybe if you're in live, you're like observing error rates and whatnot. And what end-to-end is, it's a very tiny little screen in that cockpit. One tiny dial that's giving you just one signal. Is the plane on fire or not? And hopefully you're looking at this signal before you take off. Like, are we on fire or are we not? It says nothing about what course are we on, where are we flying, how high are we, just is it on fire or not? And when we started building this, we settled on a key set of like core principles of this end-to-end test suite. So first off, this suite needs to be stable. When we run this test suite with production versions, it should always pass. Because if it sometimes doesn't, then it means we cannot really trust the tests. And the developers would start getting all sorts of friction. Like, I'm trying to do a deploy, but the test is failing, but it's usually failing anyway. I don't care. Let me just move forward to production, and then boom, there is an incident, for instance. Another really key part is this suite needs to be really fast, ideally 15 minutes or less. Because if it's running for a very long time, then you're detached a bit from doing your deployment and when it actually gets deployed. You have this context switch. Maybe you have already gone home, or to a next meeting, or to grab a coffee. So we want developers to deploy and to see their deployment go live very soon, that they can monitor and see if everything is working correctly. Also, this test suite should mirror the most common traffic in production. We ship Android SDK that customers include in their apps. And with Android SDKs, the timeline, or like the speed at which they upgrade their apps and upgrade our library is very long. So it can easily be that if we only test with the latest version of the Android SDK, then going to production, that can only be maybe 5% of our total volume. And most of the customers are using some older version. So in that case, we should really test what we have in production. Otherwise, we're still flying blind. There's an incident waiting to happen. And finally, we decided that we would exercise only the public API or the interaction surface. So what do I mean here? If we go back to this very simple system diagram, we wanted to be the bank, what a nice sentence, in this scenario, and we also wanted to be the user. So we would call the same APIs that our customers would. We would actually run UI tests, clicking the same buttons that our customers would, and we would never introspect into Veriff itself, into the system. on what it's doing. And we had a lot of debates because it's sometimes very hard to assert things or validate if you're not looking into the internals. But on the other hand, the test suite itself became quite stable because usually your public APIs are very stable as you have customers using them, so hopefully you don't break them that often. Or with a phone or with an app, the UI is also usually typically quite stable, but you might do a huge refresh every now and then. And as we agreed on all of these core principles, we also started measuring them to see how well we are doing. And as you can see, this is a snapshot from a few days ago. They are all a bit aspirational. We're close to 15 minutes, but we haven't hit that yet. Or well, we're hitting it, but only 3% of the time. But it's important to make these commitments and also start measuring them to keep yourself accountable to what targets we are hitting. Cool. Let's talk a bit about implementation. And first, also a bit of theory. So how would this end-to-end test suite work? Let's imagine we have a cloud of microservices with all shapes and sizes, and we want to test them all together. And we start with a set of services that we know always pass this test suite. We know that all of these services work well together. And as luck has it, we already have such a set. It's called production. Because if you have a problem in production, well, let's say one service is breaking another, you're having an incident. You wake up people again. They all run to their computers to fix the issue. So we can assume that production is stable. And let's say we have a service called core, a totally nondescript name, with a version 3.14 deployed into production. What our end-to-end test suite needs to answer is, if I take a new version of core, say 3.15, and I push it into a production, is the plane on fire or not? Do we have an incident? And to do that, we create the test environment, a copy of production that has all of the services except core. We take this new version of core, we deploy it into our test environment, and now we run the tests. And since our test suite is always stable, it always passes with the production versions. And if it fails here, the only thing that we have changed is this one application. So we know the new version is at fault. We can stop the deploy pipeline right here, give feedback back to the developer, something broke, you should go and fix. And if it's good, if it doesn't fail, then it becomes part of production. So now core is in this known good set of services. So let's say we want to deploy something else, then it would test against the new version of core, because that's in production. Internally at Veriff, we have this massive tool at the heart of deployments called Deploy Manager. We're very boring with names. And what it does is, from our CI services, we build Docker containers, we push them to some registry, and we also let Deploy Manager know, here is a new version of core, here is a new version of front, here is a new version of this other service. And then Deploy Manager figures out what to do with that. Let's say it's a master build, maybe it will go to staging automatically. Maybe it's a release tag, it should go into production. And finally, as a third alternative, we have these things called review environments. They're backed by Kubernetes namespaces underneath, but I'm not going to get too technical. What the important part here is, a review environment at Veriff is a copy of all of Veriff that any engineer can generate whenever they want to. So it's very useful to do things like manual testing. Like we're working on a new feature, we create the review environment, we push all the services that have this new feature enabled in there, and then we can do manual tests. Or maybe a developer is touching 20 services at a time and just wants to test himself or herself how these work together. Or maybe you want to share what you're working on with a designer. So you can just create the review environment, you get a URL, you can just give it to the designer, and they're off to go. So how it looks in the UI, for instance, I'm creating a review environment here. We have this nice little drop-down, use service versions from production EU. I can add overrides to a project, so I'm selecting core here. I could select any version I want, and then create my copy of Veriff with that version. So we already had that building block before we even started working on end-to-end. And if I go back a bit, it's very similar to what's happening here, right? We're creating a test environment that's a copy of production that is overriding some specific version. As other building blocks, we were already doing automated UI tests on Android with Espresso. We were testing our web apps with things like Cypress. So we had the knowledge, we had the know-how there. We wrote new test suites to exercise those exact things we wanted to test. And then finally, we used something we call deploy gates that ties everything together. And the very rough logic here looks something like this. So there's a new version of core built. It gets sent to the deploy manager. And deploy manager, in turn, would call some other service that we call end-to-end orchestrator and just ask, is this version of core any good? Like, can we actually deploy this? The end-to-end orchestrator would internally have some sort of queue where all of these services are being waiting to be tested. It would train this queue slowly, and eventually it would get to core. It would then fire back to deploy manager saying, give me a review environment with core 3.15. Like the same UI that I showed you, but just do that with an API call. And deploy manager is happy to oblige. It will return a new review environment with this new version of core. Once the end-to-end orchestrator, it has a review environment, so it just kicks off this end-to-end test suite with this new version. We use just a normal Circle CI or a CI job for that. It runs through all of these tests, tells back deploy manager, this version is good, everything is good to go, and then deploy manager automatically deploys core 3.15. And this can even be fully automatic. All of this can happen when you make a Git tag if you want to. Also, running the test itself often isn't enough, especially when things go wrong. So we collect all of these results into a test result database or a test result tool called Allure. It's very, very awesome. I recommend to check it out. We can see the exact steps as they happen. We get history. How often has this test failed? Is it flaky or not? How long were the test run times? All that. So we're good now, right? End-to-end test suite is running. Everything is awesome. Well, not quite. Things rarely work out that easy. So we immediately were faced with a bunch of new challenges. In this system that I did through step by step, as a single diagram, it looked something like this. And we would start looking into problems, especially with the queue. So sometimes the queue would just stop. The end-to-end orchestrator, maybe it would crash, and it would start or stop taking items from that queue. So then somebody had to go in there, investigate, figure out what's the problem, fix that, and all the while, the queue was stopped, and nobody at Veriff was able to deploy. So that's terrible. It also would sometimes slow us down a bit too much. When there were many, many things in the queue, then we would almost never hit our 15-minute target. Instead, we would maybe be waiting for 2 hours, 3 hours, just to get something through this end-to-end deploy gate, which is also terrible. So we decided to ditch the queue and run all of these in parallel. Now, there is a very small wrinkle here. There is a case where if, let's say, you have 2 services and they are deploying at the same time, and if we test one of them, it's good. If we test the other, it's also good. But if we deploy both of them production, they have some interaction between each other that would actually break. And with a queue, you would only deploy one of them because the other one would fail to pass the gate and it wouldn't get deployed, or maybe the other way around, this one gets deployed first and the other one doesn't pass the gate. So you're good there, but if you run them in parallel, then you have this race condition where both of them can pass the gate and go into production and cause a huge incident. So we knew the risk. We were looking at our deploy frequencies, and we figured at this stage where we are as a company, we don't really care. We're willing to take this risk. But I know companies like, Google or Uber or all of these really, really big ones, they have these sorts of queues. And probably maybe in a few years, we'll be back there. This simplified the whole process a lot. We moved all of the review environment handling back into the deploy manager. The end-to-end orchestrator became this very simple service that would just get a review environment, run tests on it, and then report back. Was it okay or not? So we were a lot better on that front. All of the queue issues would go away, and we would be much more stable with our test suite. Another really hard thing with these very big tests that are testing many components is debugging and understanding what went wrong. So we were already using Allure, but whenever a test would fail, we wrote this tiny little script that just assembled a very helpful Slack message that would save maybe 15 or 20 minutes of debugging, but just for the amount of friction it reduced, this was an awesome change. Anytime the test would fail, we would see what job failed, at which step, what's happened, and we're thinking of adding like screenshots right there in Slack as well, so that it could be even easier to debug. So that's one of the upsides of also using a test database or a test result database system like Allure, that it has some APIs you can use, and you can build your own stuff on top of it, which is awesome. And we have a bunch of ongoing challenges as well. So as you saw before, we're not at 15 minutes yet. That's something we're working on. And also, even once we hit it, we want to add maybe more coverage. We want to add more cases, more platforms like test iOS as well. So keeping it under 15 minutes is definitely going to be a challenge and an ongoing one. We have a very large problem right now where the data stack in production is very complex. So we have multiple tiers of databases. They have shards, and they have like replication arrows and whatnot. And in this review environment, we have one single database that is sort of like playing at all of this complex system we have in production. So in some cases, we see problems where either they work in review environment and they don't work with this complex data stack, or vice versa, something perhaps expects this very complex structure, and it only works in production, so we are having a hard time testing it. So we're currently working very hard to lessen the gap, to bring us closer to production, and that's always an ongoing work as well. The other really huge challenge is local development here is a real pain. And by local development, I mean developing this end-to-end test suite itself, like running a test. Because you have so many moving parts. You have to create this review environment. You have to deploy all of these things. You have to run this end-to-end test orchestrator. So currently, the best way we have for doing this is to just run the end-to-end test suite, just with maybe some specific branches or something like that. So the development cycle into making improvements into the system itself is very painful, but we're working on it. Debugging issues is still hard, even though we can add tools like Allure on top. If you're testing 100 services at the same time, and only at the edges, it's very hard to figure out what went wrong when it fails. So we haven't figured this totally out as well. If anybody has any ideas, find me. I'm happy to hear any sorts of solutions to this. And we also found that we need a dedicated person for this. So when it started out, it was a bit of a shared project between developer experience, DevOps, quality engineering, but it wasn't a full-time job for anyone. So it was a bit of a side project for all of us. Maybe we would have more time on some quarters, less time on other quarters, and you would see the quality of this test suite starting to degrade. And that's something I think we're fixing very soon as well. And not to finish this on a very sour note of all of these problems and challenges, a few key takeaways as well. We are catching issues before they hit production with this. Like every month we are seeing there is a failure, and if it had gone through, there would have been an incident. So it's very important to celebrate these. Share these with your team, because you've made this massive investment into building all of this machinery. So whenever you actually catch a bug, definitely celebrate it. And there's a question when you go home or back to work from this conference, like, should you introduce end-to-end at this level? Maybe. If you have the right product at a certain size, I would say yes, because you can get a lot of coverage with a few simple tests. For us, it was quite easy because our business is so transactional. We have users going through this flow. The whole thing is over in 5 minutes. We can write a test to cover that. Maybe if you have a very complex product, like let's say GitHub, they have so many key flows that all should work. So I don't know what like an end-to-end test suite for GitHub would look like. So maybe, but plan accordingly as well. It's a massive investment in like time, people, money, and it's an ongoing maintenance. It's never going to be, we just wrote this test suite, deploy it somewhere. Now all of our services are getting tested before they hit production. So it definitely needs some planning upfront. And that concludes the overview of how we did our end-to-end test suite at Veriff. Do we have any questions? And I'm on Twitter as well, so you can always ping me later.
Hey, thank you very much. I really loved that talk.
Thanks.
But I have to say, I hate the word end-to-end tests. That's because it's such an overloaded term.
Yes.
Nobody actually knows what's one end, what's another end. And that's also where my question stems from. So in your setup, how do you actually include mobile test automation? So do you also run real automated espresso tests, for example, somewhere in the cloud? Do you have, I don't know, some device framework that you're using? So it would be good and interesting to hear more about that.
Yep. So first off, I totally agree with end-to-end. Even at Veriff, there are like repositories that have their own end-to-end tests that test their service end-to-end. So even when I was like titling this talk, I had to add this system-wide before it to like really clarify what I mean. And regarding mobile, we have both. So the mobile SDKs have their own set of tests that they run through each pull request and all of these steps. But they also participate in the end-to-end. And it's exactly that. We run them on not real devices. We run them on emulators in the cloud. And they like press the buttons, send the requests off, do things like that.
Okay, so they're decoupled, basically.
Yep.
Great, thank you.
Hi, Madis. Thanks for the talk. Great. I was wondering, so, you know, this is kind of optimizing for time between defects on production. I was wondering how you deal with issues that do get into production.
So let me unroll. There is like a whole process there. Like obviously we do live monitoring. Any service automatically gets like a bunch of alerts attached to it. Whenever we hit alert, an automated phone call goes out. So then people step in, start looking at this, figure out what the problem is. And sometimes, as before, I think the previous talker said, all it takes is a restart. Like restart the service, we're going again. But sometimes it's a bit more complex.
Okay, thank you.
Of course, once the incident is over, we hold a post-mortem to figure out where did we fail, where's the gap, where should we write new tests? Because we use like unit tests, functional tests, all of these tests as well. Yeah.
I guess one thing I was wondering, you know, because you have active monitoring and you seem to have some good observability tools. Do you have like a game plan, you know, when the issue is recovered? Do you do rollbacks or things like that? Or do you kind of wait and try and fix the bug before? I guess it depends.
Yeah, it's, I think, I'm not sure. I'm in DevXP, so I'm not in like DevOps or those parts. But obviously, rolling back is the first thing to do. Maybe restarting the service also. I think it might depend on what the failure is looking like. And then try to fix it from there.
Oh, thank you very much.
Thanks for the talk. I'm also a huge fan of the challenges that end-to-end testing brings, so it's fun to be working in that. I wonder how many, is it used for your developers actually as a tool during development? And that leads to the question, how many of your end-to-end tests actually fail because of a problem? And could you maybe imagine actually deploying stuff immediately to production and let the tests verify that the change is okay after it's already running, to completely go away from this time between commit and deploy?
Yeah. So I'll answer it in two parts. Developers can use it, and sometimes they do, like when they're making a very large sweeping change, just to verify that things are working. But what we're always messaging internally is that this is not, like this is this very tiny signal. We have very, very simple tests here. This is not like full coverage by any degree. You should still write unit tests. You should still, in some cases, do manual testing, all of those things. For automation, I think most services don't do it in a fully automated fashion. There's still like one final button click for most of the services we deploy. But the functionality is there. So any project can decide, and they can enable it today. Just doing a tag in GitHub can take it all the way into production immediately.
Hey, Madis. Just curious, I have two questions. First question, I didn't see in the presentation. If it's not a secret, do you guys have the communication pure REST or it's event-driven?
Sorry?
Is the communication between microservices pure REST or is REST interface with event-driven? Is there a queue behind the microservices?
Okay, so there are multiple answers here. As we have grown, there are like different ways. So we use REST. We use GraphQL between some services, and we also have a message bus or like message passing. So we use all of everything. Like it's typical at a certain size, you have so many people and so many teams. We give them a lot of freedom, so they are free to do what they want, and then you can end up with like many solutions going on at the same time.
Cool. And second question about the slide where you had the Kubernetes clusters. You mentioned that pretty much any dev can have the namespace or the cluster with specific versions of the services. Is that a whole cluster on demand?
What do you mean, like the infrastructure, like supporting
Yeah, like
this?
for example, I just want to pull out, like let's say I want a new cluster with the latest versions of all microservices, and is that just going to create it from scratch, or there is an existing cluster already with those services up and running?
No, it's always from scratch. Yeah.
So you have like around 100 devs, 10 or more teams, and each dev can get a cluster on demand.
If they want to, yes.
Cool. Okay, thanks.
More hands? Okay, we have still 5 minutes, so please think the next question. Madis, do you deploy to production on Fridays?
Sometimes. But in Deploy Manager, we have this huge warning saying, please don't do it. And we try not to. I think I pulled out statistics for this recently, and it happens very rarely. So before afternoon is fine, though. After Friday afternoon, then no, you shouldn't deploy.
What about Saturday and Sunday?
Well, that's a given, I would say. Like if Friday after afternoon is off, so is like Saturday and Friday. And we even have an integration with like these public holidays, so you get a warning about that as well.
Thank you. Okay, but if there is no more questions, then I walk back, take the box with your present and come to the stage, and you have still time to raise your hand. So seems that we can finish. Thanks a lot. It was really interesting.
Thank you. Thank you.